Okay, so we're picking back up in derivatives, right? I'm going to make you guys, do more of these. But our next section is the sum and difference rules. And the sum of difference rules just basically says that if you have a sum or difference, so if you have two terms being added, and you're doing the derivative of them, you do the derivative of each individual term. Same thing as subtraction. That's all it's saying. Okay, it's just saying there's no special rule for a sum, you just do each individual term. Do we need a reminder on A to get us back in the groove for the rule? Okay, and most of this is just power rule. Okay, so f of x is defined here. We're going to find f prime of x. Okay, what do you guys remember? X cubed.
3.
3x squared. Just remember you take the power multiplies out front, so 3 multiplies out front, and you subtract 1 from the current power. So that's 2. Are we there?
Yes.
Okay, then what?
10x.
Minus 10x, because 2 times 5 is 10, and 2 minus 1 is 1. Then what?
And then
Plus 2, because you have an invisible power of 1, you multiply out front. 1 times 2 is 2. And then when you subtract your powers, 1 minus 1 is 0. So when you have a power of 0, you don't need to write the x.
That's it.
Minus 7.
No.
What?
To the 0. It's to the 0.
Because the derivative of a constant is always 0. That was the very first rule we did yesterday. Okay. Basically, and here's what I look at. There's no power there to subtract 1 from, right? So if there's no power to subtract 1, now this number is just done. Okay, are we there on that one?
Is that the answer?
Uh-huh.
Oh.
Okay.
I mean, yesterday I know I was writing more steps out, but do I really need to write out the 2 minus 1 and things like that?
No, I just thought we needed to solve it.
Nope. We're just doing derivatives. Okay, B, y is defined. We're finding y prime. Derivative of 2/5 x to the 5th.
What's 2/5 times 5?
And what is 2/5 times 5?
2.
Because 2 over 5 times 5 over 1. 2/5 times 5? 2 over 5 times 5 over 1. So it's just going to be 2 x to the 4th plus derivative of x to the 4th,
4x.
4x to the 3rd, plus the derivative of 3x squared, 6x, minus the derivative of 1,
0.
Bye-bye.
Get out.
0. So constant terms are gone. Okay, C. Now, it's a personal choice, but for me, I'm going to start by rewriting the original equation, because what is the cube root of x? That is x to the 1/3 plus 5x to the 1/2, because it's a square root. Okay, not that you have to rewrite that, but to me, I think it's helpful if we have the visual. Okay, derivative.
Um,
1/3 x and negative 2/3. Because at that point, when you do 1/3 minus 1, it's 1/3 minus 3/3, so negative 2/3. Okay, plus I'm going to leave it improper though. I'm not going to say 2.5. 5 halves. Okay, half times 5 is 5 halves. X to the negative 1/2. Yep. You guys there? Now, go me one more step. Don't leave negative exponents. So what are you saying on the first one? Sorry. 1 over 3x to the 2/3, okay, plus 5 over 2x to the 1/2. And I just have my answer like that. You could go radicals if you wanted to, but you don't necessarily have to. Okay, D. The only thing I would encourage you to think about before you take the derivative. 5x to the 3/2, 6x to the 5/3, those are good. What about 4 over x? What is that?
4x.
Yeah, that is 4x to the negative first, yes? When you take that x out of the denominator. Okay. Y prime, here we go.
Um,
15 halves x to the 1/2 is 5 times 3/2. So 5 over 1 times 3 over 2. Okay. Minus
10x. Yeah.
10x to the 2.
Are you guys with us on the 10? 6 over 1 times 5 over 3, 30/3, which is 10. And I'm assuming you can subtract the 1, okay? Okay. And
4 over x minus
Negative 4x to the negative 2.
I'm going to go with the negative 4x to the negative 2. Remember, instead of 4 over x, I thought of it as 4x to the negative 1. So negative times 4 is going to be negative 4, and then subtract 1, you're at x to the negative second. And then for final answer there, 5 halves x to the 1/2 minus 10x to the 2/3 minus 4 over x squared. Forgot there's 2 more at the top of the next page. You're getting the hang of these, right? No one's complaining. I'm hearing bits and pieces of answers from everybody, so I feel like we're all together.
yeah.
H of x is defined. H prime of x. Derivative of 3x squared. Oh, well. Derivative of 3x squared is 6x. What I probably should have thought about, what is 4 over x squared before we take the derivative? Yeah, that's really 4 minus 4x to the negative second. So when you take the derivative, what's that become?
Plus
Plus 8x to the what? Negative third. Okay, you guys with it?
Yeah.
Because it was negative power of negative 2, we pulled it up top. Negative 2 times the negative 4 out front makes it positive 8. Subtract 1, you're at negative 3. What is this 2 square root of x? It's really what? 2x to the 1/2. So when you do the derivative of 2x to the 1/2, what do we have?
x to the
Okay. It's going to be x to the negative, did you say 1/2, I hope?
Yeah.
Okay. Yeah, because half times 2, half of 2 is 1. And just subtract 1 from your power. Okay, write your final answer. So I have it written as 6x plus 8 over x cubed plus 1 over, and in this case, for whatever reason, I actually wrote 1 over the square root of x. You could also have it as 1 over x to the 1/2. That's equivalent. As always, know it's changeable, right? Okay.
Okay.
One more. Thoughts here to get us started.
X to the negative first. What? No.
1x to the negative 1. Right?
Are you talking about this x here?
Yeah.
Yeah.
So you're, okay, there's a couple different routes we could take this. So you're saying it's x to negative first when we take it up top, yes?
Yeah.
But where is it up top?
In between the. Oh. X squared.
Because what it is all these terms, it's the top divided by the bottom. Now,
So it's under everything.
Oh my god, yeah.
it is, I would think of it as under everything in this scenario.
We split each term up, and then you can like do like the 8x squared divided by x, and then 4x squared divided by x, and then the minus the b minus 3x to the first thing.
That's what I would do in this case. Because our denominator is just an x, divide. Every term gets divided by x. So 8x cubed divided by x becomes what?
8x squared.
8x squared. Plus 4x squared divided by x becomes 4x. Minus, what about 3 divided by x? 3 over x.
3x to the negative.
3x to the negative first for the purposes of taking the derivative. Right? Okay. Now let's do the derivative. Okay. Derivative of 8x squared is,
16.
the derivative of 4x is, 4. Basically, when you have just the x to the first, it drops off. Okay? Or 1 minus 1 becomes 0, and anything raised to 0 is 1. Okay? Minus derivative of 3x to the negative 1. Plus 3x to the negative second. If I rewrite this, just for the sake of the last term, 16x plus 4 plus 3 over x squared. Okay? Okay. We have a few, that's your power rule. Okay, all of that kind of correlates together into the power rule. As you see, the more we use them, the easier they become. It didn't take you guys long to get back into the groove from yesterday. We've got a couple other specific derivatives we're going to learn. And, you know, the power rule applies for any where it's a variable raised to a power. These others, okay, well, we're going to talk about the derivatives of sine, cosine, e to the x, and natural log of x. These aren't just a power rule, okay? And so that's why we have to have special derivatives for them. So we're going to talk about these. Now, first of all, we're going to talk about derivatives of sine, cosine, and tangent. We're going to really focus on sine and cosine if we recall. I don't think we do much with tangent yet, but maybe it comes up in homework. I don't remember. And notice here, okay, it talks about the derivative of the sine function is the cosine function. Consider where the sine function increases, the cosine function is positive, and vice versa. And I don't know. Okay, so I'm just going to go ahead and fill these in, and then we can look at some of the graphs. But these will be ones to memorize. The derivative of sine function is cosine. So the derivative of sine x is cosine x. The derivative of cosine x is negative sine x. So they are opposite each other, except there's a negative involved. And the derivative of tangent is secant squared x. Okay? Those are ones that the more we use them, they're going to sink in, they're going to get memorized. But they just have to land in that memory bank. Okay? Now, as we look at this here, what they suggested, I guess I left this on this page too, is that we look at some relationships here. And, okay, first of all, what curve is this that we're looking at? What is this curve? We learned this last year in pre-calc. What is this? What? Yeah. This is the curve of sine x. And the idea here okay, if we think about this, okay, so first of all, on sine x, we have a min, or a max, excuse me, and a min, yes? When we have a max or a min, what's the derivative at those maxes and mins?
0.
The derivative is 0. So what's going to happen then? If the derivative is 0, notice that means there's going to be a 0 at pi over 2 and a 0 at 3 pi over 2. Which, by the way, what is this the graph of? This is the graph of cosine, yes? So I want you to make that connection there, and that's what I'm trying to get you guys to realize is that, you know, right here, the derivative is 0. So what do zeros recommend? Or zeros represent? Well, this 0 is a max, and this 0 is a min. Okay? If we go back to the original, okay, what's the graph doing at the first part? This graph is going up, yes? It is increasing. An increasing line has what kind of slope? A positive slope. What do you notice right here? From 0 to pi over 2, my slope is positive. Okay, this goes back, you remember the slope graphs the other day, right? Okay, what's my graph doing from pi over 2 to 3 pi over 2? It is decreasing, yes? If it's decreasing there, what is it over here? It's negative. And of course, what's happening on the end here? It is increasing. An increasing slope is positive, and notice over here that this is a positive slope. Okay? Or positive value. I'm trying to think, was there anything else I want to connect here? Okay. The other thing we can connect here, right there, you'll notice, which way do I want to make that connection? Right here, notice there's a 0 here. What do you notice over here? I'm trying to think, do I want to say it's because there's a 0 or because that's an inflection point? Might be better to say because that's where our concavity changes. We go from being curved down to being curved up. And so over here it's represented as a min. Okay? So there's kind of your connection. As I said, those are just 3 derivatives to represent, but I wanted you to connect it. Okay, y is sine, over this here is cosine, realizing this is the derivative, yes? Cosine is the derivative of sine. So this is our slope graph of sine. Okay? Now, not that we always have to look at those connections, but it's one to kind of prove how the connection works. And we're only going to do that one. We could go through all of them, but no. Now, we're not going to use the calculators too much here, but I just want to kind of introduce it and mention it. You can graph derivatives on a calculator. Okay? You can only find the value of a derivative when we have a value to plug in. However, you can graph something on the calculator by putting into your graphing window our derivative form. Okay? You put it into the derivative form, but the key is instead of putting a value that you're going to evaluate at, so like instead of saying, okay, at x equals 2 pi, you put in x. Okay? And so this is Math 8. This is what we did the other day. It's also Alpha F2 and whatever it is in that shortcut menu. Let me switch over real quick. Okay, so for instance, if I want to do the derivative of cosine, okay, it is in our alpha F2 menu. So alpha F2, it's in deriv number 3 here. You type in x, what you want to take the derivative of, so like if I say sine x, and then if you're in our regular screen, we want to know what the value of the derivative at a certain point is, we could say at x equals whatever. But if we just want to see the graph of the derivative of sine, you're going to do that. And now, this is supposed to be the derivative of sine. Notice this isn't a sine graph, is it? And here's my proof that this is cosine graph. If I go down here and graph cosine, notice it's tracing over it. Okay? So there's a way to graph the derivative. There are random occasions where that will be helpful in calculus, being able to graph the derivative. Okay? The nice thing about graphing a derivative is you can visually see what's going on. Okay? So just remember that option is out there. Obviously, you know, we don't use the Inspire. We're using the TI-84 Plus. Okay? So, okay. Anything there? Okay. Okay, 2 more pages. Okay. In example 5. Okay, we're asked to go back to our limit definition, right? Yeah, it doesn't go away ever totally. So, yeah, pretty much. Okay, so we're asked to use the limit definition for the derivative for each of the following trig functions. So basically, I told you the derivative of sine is cosine, and the derivative of sine is cosine, or sine. Derivative of sine is cosine, derivative of cosine is negative sine. But we're going to have the opportunity here to verify that. Now, as much as we all dislike proofs, there's good stuff to them, okay? Knowing how they work is helpful, okay? Being able to see the issues there. Now, do notice, it says we're going to verify using the sum and difference formulas that we learned in pre-calc. Okay? So, okay, a couple of things before we get started. First of all, this is one of our specialties to memorize. The limit as h approaches 0 of sine h over h
1
is equal to 1. We're used to seeing it with x's, aren't we? But it doesn't matter what letter variable they throw in there. Okay? While we're on that, the limit as h approaches 0 of cosine of h minus 1 over h is 0. Okay. Hint, hint, those are going to be in there is what they're saying, right? Now, okay, guys. Purple paper and trig. Purple paper and pre-calc, okay? This is where your brain's going. Sum and difference formulas. We had sum and difference formulas for sine, cosine, and tangent.
Right here.
Okay? Nope, Augie's got the purple paper.
Where's it at?
Sum and difference
Oh, yeah.
formulas.
Yeah. Oh, no. Oh, wait a minute. Cosine x times cosine h
Uh-huh.
minus sine x sine h.
Uh-huh. Okay, so the cosine one, it was the same. If you're thinking about the order we learned them in, which is where my brain always goes, the cosine one was the second one we learned, and it's cosine, cosine, opposite sine, sine, sine.
Oh, those
That doesn't sound right, but or it just sounds weird to say. But so the cosine one was cosine, cosine, and then you use the opposite plus or minus sign, and then you're doing sine, sine. Okay? Now, the sine one was the first one we learned. Sine x, cosine what?
X.
Nope.
H.
H.
No plus.
Keep it plus. It stays the same plus or minus sign.
Then you choose.
And now you reverse this. So now it's cosine x and sine of h.
I don't know. There you go.
Okay? Okay. So those are your sum and difference formulas from pre-calc. Do some of those things we learned in chapter 5 last year still pop up and apply?
Yes.
Oh my goodness, yes. Okay? They do. Okay. So our job is to show that the derivative of sine is cosine. Okay? So we're trying to show that, actually, I'm going to do this over here. d dy dx, or dy dx of sine. So that just says the derivative of sine. And eventually our job is it's going to equal cosine. But they asked us to use our limit formula, yes? So we're going to use the limit as h approaches 0. Now, f of x plus h. My function is sine, so I'm going to say sine of x plus h minus f of x, so minus sine x all over h. Okay? Now what?
Sine of x plus h is sine x.
Okay? Sine of x plus h. Can we use our formula that we just created from above using our sum and difference formulas?
Yes.
So sine of x plus h is going to be replaced with sine x cosine h plus cosine x sine h. Don't forget there's still a minus sine x, and it's all going to be over h. Okay. Trying to remember where I want to go next. Let's look at two of these terms have a common factor. Two of these terms have a sine x, yes? So what we're going to do is we're going to kind of rearrange the top. And as I rearrange the top, I'm also going to factor out sine x of those two that will factor out. This other term, the cosine x sine h, I'm going to push to the end. Am I making any sense?
Yeah.
So if I factor out sine x, from this first term, if I factor out sine x, I'm left with cosine h. And then if I factor out a sine x from minus sine x, I'm left with minus 1. And then don't forget, we still have the cosine x, sine h, and of course, it's all over h. Now, I don't know if you see where we're going yet, but remember we have these two special limits that you were told to recall. Okay? Those pieces are in there. Okay? There is right here a cosine h minus 1. And then remember, this h goes under everything, right? Over h. Over here, there's a sine h over h. And so what we can do is we can take this and split it into two fractions. Okay? The idea that, for example, do we need the 2 plus 1 over 5 is the same as saying 2/5 plus 1/5, yes? That's the idea that I'm going to do here, is I'm going to take this and split this into two limits. So we're going to have the limit as h approaches 0. And my first one is going to be the sine x. And then I'm going to go ahead and kind of break this up as a separate fraction, I think. Trying to save my steps here. Times the cosine h minus 1 over h. Okay, so that represents the first part. Plus, I'm going to do a second limit because I'm breaking this up into two pieces. Limit as h approaches 0. This one is cosine x times the sine h over h. Okay. Now, are you there? What do we know about the cosine h, the limit as h approaches 0 of cosine h minus 1 over h?
0.
It's going to be 0, yes? Okay. What do we know about the limit as h approaches 0 of sine h over h? It's going to be 1. Okay. So, this whole first piece. Limit as h approaches 0 of sine x times cosine h minus... All of this is going to be what? 0, because 0 times anything is 0. Plus. Okay. This limit's going to be 1. The limit as h approaches 0 of cosine x. Do we have a spot to put the 0 in? I mean, this piece is 1. The sine h over h is 1, so that's gone. It's just the limit as h approaches 0 of cosine x, which is just going to be cosine x. Yeah, you have to be careful because some of them are x's, some of them are h's. You have to be very careful here. And what is 0 plus cosine x? It is cosine x. So we just showed that the derivative du dy dx of sine x is indeed cosine x, using our definition of derivative. Okay? Now, what are you going to guess that can happen on the other one? Same idea, right? It's just the different pieces. Debating. Probably be better. We really want to make sure we get the back page done. Huh?
On there first.
Yeah. Let's go to the back page first. because there's a couple other basic rules that we've got to learn. But then we'll come back if we have time on that one or what, we'll see. Okay. So, skipping that page for the moment, it works pretty much the same as the first part. Two other basic derivatives. Okay? The derivative of y equals e to the x is the only function that has itself as its derivative. So the derivative of f of e to the x is e to the x. Derivative of e to the x is e to the x. And then the other one we're learning here is the derivative of natural log of x is 1 over x. Okay? So what we're saying here is the derivative of e to the x is e to the x, and the derivative of natural log of x is 1 over x. Officially it says as long as x is greater than 0, and that's just because you can't do the natural log of a negative value. Now, we're going to use those two derivatives, but here's the catch, folks. Use the laws of logarithms to find these derivatives. Okay? So, for instance, in A, we just learned the derivative rule for natural log of x. Did we learn a derivative rule for natural log of x cubed? No. And there's a lot more to that. But, okay, so think log rules here. I may have to, I ended up making copies of some printout last year for the calc kids. I may need to pull that out again. But there's a power rule here. How can this be rewritten? A power on a log can be rewritten as a coefficient out front. Okay, and that's the thing. Right now, we don't know enough to take the derivative otherwise. So eventually we will, but right now we don't. So one way to take this derivative is to take the 3 and move it out front and rewrite this as 3 natural log of x. Now you can take the derivative What is the derivative of natural log of x? 1 over x. And then what's out front of this? 3. So it's 3 times 1 over x. Okay? And then I'm going to put it together. And so what is 3 times 1 over x? 3 over x. And you can go ahead and go straight to the 3 over x, which is what I normally would do. Okay? But the derivative of natural log of x is 1 over x times this coefficient of 3 that's down here, so 3 over x. Okay? So the ones, they're not giving us basic ones to start off on. But the ones that they're giving us, we have to apply log rules. Okay? B, it's another natural log, but do we know how to take the derivative of two things being multiplied together? Not yet. Okay? That's maybe 2/6. I forget. It's coming up soon. So, multiplication inside a log can be rewritten as 2 logs being not multiplied, but added. Okay, this is one where multiplication and addition go together. So multiplication within a log can be rewritten. So this is the natural log of x squared plus the natural log of e to the x. Okay? Now, we have natural log of x squared. Again, we know how to take the natural log of the derivative of natural log, but we don't know how to do the derivative of natural log of x squared yet. So what am I going to tell you to do with that 2? Take that 2 and put it out front. So 2 natural log of x plus, what are we going to do over here? Same thing. And I'm going to say x times the natural log of e. Looks a little different on that one, I know. Okay, let's try derivatives. Derivative of 2 times the natural log of x. What'd you say? 2 over x, yes. And you can write it, are you guys okay with just going to 2 over x? Okay. Now, okay, this next one. I probably should have talked about this at the end, but natural log of e is a value, what do I want to say that we should know?
Isn't it 1?
It is 1.
This isn't base with
Yeah, yeah, okay. I was trying to remember how I wanted to explain that. Yeah, when the bases are the same, right? So since those are e's, the natural log of e is just 1. So now what are we doing the derivative of? You're doing the derivative of x, or 1x if you will, right? In other words, natural log of e is just 1, so this is the derivative of 1x. What's the derivative of 1x? 1. And I'm going to stop there. 2 over x plus 1. Okay, they make you think a little bit more than they need to on these, but it's good stuff. Okay. Ready for C? H of x is the natural log of x minus 1 over x.
Wait. It's a 0.
There's no tricks with natural log of x. That one we're ready to take the derivative of.
Oh, we have to take the derivative.
Now, what about 1 over x? What about it?
Wait.
It would be
X to the negative.
yeah.
Yeah. Before you take the derivative, natural log of x needs nothing done this time. And realize that this is x to the negative first. So are we pulling back the power rule from the beginning of the lesson? That's basically what we're doing here. So, derivative, h prime of x. What is the derivative of natural log of x? 1 over x. What's the derivative of minus x to the negative first?
X to the negative second.
Okay, it's going to become plus x to the negative second. Are you with her? Which, I'm going to rewrite this as 1 over x plus 1 over x squared. Okay. D. Division within a log can be rewritten as 2 logs being subtracted. Okay. Multiplication within a log can be rewritten as addition. So realize I'm going to take these logs and split them up again. The natural log of 2e to the x is going to be the natural log of 2 plus the natural log of e to the x. Now, officially, the natural log of 3x is the natural log of 3 plus the natural log of x, yes? But, what's the but here? What are we doing? We are subtracting this log. So I'm subtracting the natural log of 3 plus the natural log of x, which means it's really going to end up as minus natural log of 3 and minus natural log of x. It would have been like if I would have written it minus of natural log of 3 plus natural log of x. You would have to distribute the minus. Okay.
1/2.
Not exactly. What is the natural log of 2?
2. No 1. Right?
Okay, we don't know, but is there a variable?
Yes. No.
No. There's not a variable. Okay, there's no x. Are you with me on that? There's no x. So that means natural log of 2 is a number. A constant, if you will. What's the derivative of a plain old number?
A number. No, it's 0.
0.
Okay.
Right?
I did. That was like true.
Okay, I missed it if you said it. I'm not going to say you didn't say it. I'm just going to, I missed it then.
Yes.
So are you guys with me that the derivative of the natural log of 2 is 0? The natural log of 2 is just a number, and the derivative of any plain old number is 0. Natural log of e to the x. Now, I guess earlier we wrote the x out front, didn't we? But, I mean, you can also realize e to the x, this is x, and what's the derivative of x? 1. Does that work for you? Minus, derivative of natural log of 3. 0, because it's a number. Minus, derivative of natural log of x. 1 over x, because it's a variable, right? We're actually doing the natural log. Or doing the derivative. This cleans up to be 1 minus 1 over x. Okay, guys. E, do you see it? This is a whole bunch of multiplication, which means it can be split up into addition. Also, what about those exponents? The exponents can be moved to the front of each piece, the coefficient of each piece. Can we do this all at once or no? So I see 3 things being multiplied. So I'm going to take it into 3 logs. The natural log of 4 plus, now, what about the natural log of x cubed? 3 natural log of x plus, so natural log of e to the x, or if you want to, you can say x times the natural log of e, or you can just leave it as natural log of e to the x, either way. Okay? I think I'm ready to take the derivative. Derivative of natural log of 4. 0, because it's a constant. Derivative of 3 natural log of x.
0.
There is a variable here. There is an x. The derivative of natural log of x is 1 over x times the 3 makes it 3 over x plus, well, remember, natural log of e is 1, so the derivative of 1x is 1. So our derivative is 3 over x plus 1. Okay. Real quick, I'm going to rewrite g of x. I guess we have a couple minutes. Pi e to the x is fine. Minus, what is this going to be? X to the
Negative 2/3.
-2/3. Okay. Now I'm ready to take the derivative. Okay. They wait till the very last example to throw in e to the x in this sense. What's the derivative of pi e to the x? No? No?
0.
No?
Pi e to the x.
DNE.
Augie wins.
With
It doesn't change.
No. Because what's the derivative of e to the x?
E to the x.
Is the x. So if you have, and pi is just a number, right? So you just multiply it back in and it's still there. Okay, then minus the derivative of x to the negative 2/3.
plus 2/3 x to the negative 5.
Are you guys there? Negative 2/3 times negative 1 is plus 2/3. Negative 2/3 minus 3/3 is negative 5/3. Clean up. Pi e to the x plus 2 over 3x to the 5/3. Okay. I'm glad that I skipped that one problem to get to the last page because that was definitely more worth our time. Okay. On that previous page, whoops. I mean, obviously walk away that the derivative of sine is cosine. The derivative of cosine is negative sine. This proof, you could see it online. It's very similar to the one up above. Unless you really want me to go through it, but it's very similar. Okay. You could grab it off the website if you want, off Schoology. Okay.